In problem 5, identify the center of this element. The center of this circle is point G. All the diameters that are illustrated here, a diameter is a chord or segment that passes through the center of a circle, has endpoints on the circle. So CF or FC, either of those names would be fine for describing or identifying your diameter. Again, you'd only need to label it one of those two ways. Name all radii. Well, as far as the radii that are shown, they're all the segments that originate from the center and end on the circle itself. So it does have to start with point G and then ends with any point on the circle. So segment GC, GD, GE, GF, those are all the radii that are actually shown. The ones that aren't shown, you could imagine segments connecting G to A and G to B. Those would also be considered radii. They're not actually shown on the illustration, but they would be considered radii nonetheless. In this next part, they're asking you to imagine that FC is given a length of 8. If that's the case, then what's the length of GD? Well, if the diameter is 8, the diameter is twice the radius, so that means each of these radii is going to be half of 8 or 4, which means GD, which is also a radius, is going to be a measure of 4. In this diagram, the next question asks if in this circle E, G, and C were non-collinear, so E, G, and C as they are sitting right now are non-collinear, then can the distance from C to E be equal to twice the distance from G to C? And the answer is no. If that were the case, you can't have two sides of a triangle that are greater combined than the third side. And so the diameter is the longest segment or longest chord in a circle, so CE cannot be the same length as the diameter. So in this particular case, the answer is no. However, the last problem asks if E, G, and C are collinear. So basically what that's saying is if E was located right here instead of here, now would the distance from C to E be twice the measure of G to C? And here the answer would be yes, because now it is a diameter, and if that's the case, then it would be equal to twice the measure of the radius.